started with a warm-up. So let's take a look at the warm-up. So it says that each participant of a charity raise made a donation D of $15.50 to a local charity. Which subset of real numbers best describes the total amount of money raised? So this is similar to the one we looked at yesterday, where the number of participants we said could be 0, no one could show up, or 1 or 2 or 3 or 4 and so forth. So we said whole numbers. So if whole numbers describes the number of people who are participating, and each person 0, 1, 2, 3, 4, so forth is donating $15.50. So let's think about how much money would be collected. So if there's 0 people, then $0 are collected. If there's 1 person, then $15.50 is collected. If there are 2 people, that would be $31 and so forth, by multiplying the number of people by the amount of the donation. So we're seeing 0 and $15.50 and 31. We're thinking about what types of numbers are represented there. And we know that the subset that best describes those numbers that I just listed would be the rational numbers. Rational. Now, someone in my one class said, well, but rational numbers include negatives, and we can't have negative amounts of money. That's true, but we're not saying that every number that's part of rational numbers describes this scenario here. What we're saying is all of the numbers that would describe this scenario are rational numbers. Okay, and if I didn't say rational, if I said something that didn't include negatives, then I wouldn't be able to include those decimals. And $15.50 has a decimal, so that means it has to be, the subset has to be rational. Next one, simplifying square root of 54, x to the 18th, y to the 5th, and z to the 8th. So first I'm going to simplify the square root of 54. Now, you don't need to do a factor tree in the prime factorization here, because you can simplify square roots the way you always have, which is just getting a perfect square factor of 54, rather than doing the factor tree. The factor tree really will just do for cubed roots or fourth roots, numbers that we don't necessarily know perfect cubes or perfect exponents of 4 and that sort of thing. So here we'll just start with 54, and I'm thinking, okay, well, 9 and 6, so that would be the square root of 9 times the square root of 6, which is 3 root 6. Now, I'm going to take a square root. Square is even, which means I'm going to put an absolute value around everything to begin with here. So I'm dividing 18 by 2 and getting 9, so x to the 9th, 5 by 2 and getting 5 halves, and 8 by 2 and getting 4. And I'm putting absolute value around that. Remember, though, in yesterday's lesson, we talked about the fact that the only ones who have to stay inside the absolute value are the odd exponents. 5 halves and 4 are not odd. Therefore, I'm going to take those out. So y to the 5 halves and z to the 4th, and then just x to the 9th, because it has an odd exponent, is going to stay inside the absolute value. And that is my final answer. Okay. Next. So we just worked on more simplifying of radicals, since that's pretty new to us. So let's look at the next one. Go ahead and put that in your notes. And actually that first one, 81, cubed root of 81, a to the 5th, b to the 12th, we did that one yesterday. So let's just start here then. So this is a square root. I know that I'm going to break the 12 into perfect squares, so 4 and 3, so 2 root 3. And I see square root, so that means absolute value. I'm dividing 14 by 2 and getting 7. I'm dividing 6 by 2 and I'm getting 3. I'm dividing 3 by 2 and getting 3 halves. And I'm dividing 2 by 2. 2 by 2 is 1, so that's b to the 1st, or just b. So I'm putting the absolute value there. Now remember, I only need to keep the odd exponents, so 7 and 3 and 1, the even exponents don't have to stay in the absolute value. So 2 root 3 a to the 3 halves can come out of the absolute value, and then absolute value of x to the 7th, y to the 3rd, b to the 1st stays inside the absolute value. Couple more. Go ahead and put this next one into your notebook. So I'm taking a cubed root here. Cube root is when we're going to use the prime factorization, since we don't necessarily know what perfect cube goes into 16. So I'm thinking 8 and 2. I'm thinking 4 and 2. I'm thinking 2 and 2. And then I'm realizing, oh yeah, I knew that. 2 to the 4th is equal to 16. But I'm taking the cubed root. And remember, when we're taking cubed root, we want a number cubed. So rather than writing 2 to the 4th, I'm going to write 2 cubed, and then I need one more 2. So I have 4 2's total. And now I can take the cubed root of 2, which is 2, and I'm left with the cubed root of 2. So 2 cubed root 2. Now we're ready to take the rewrite these as fractional exponents. This is a cube root. Cube is odd. Odd does not have absolute value. So 6 divided by 3 is 2, so x squared. 2 divided by 3 is 2/3. And 15 divided by 3 is 5, so r to the 5th. Again, this was an odd root, so no absolute value. Also notice the only thing that keeps the radical is just the 2, the x squared, y to the 2/3, and r to the 5th do not have a radical over them. That is my final answer. Next one, copy that one and try it. So 18, that's 9 and 2. That's 3 root 2. With the variables, I see even roots, so absolute value. I'm dividing 4 by 2 and getting 2. I'm dividing 5 by 2 and getting 5 halves. And I'm dividing 10 by 2 and getting 5. And I decide to keep just the odd exponents inside the absolute value. The rest can come out. So 3 root 2 x squared and y to the 5 halves. And then the absolute value of z to the 5th. And we have one more for today. So cube root of 56. So I'm doing my prime factorization. So 56, 7 and 8. 8, 4 and 2. 4, 2 and 2. So I have 2 cubed times 7. And I am taking the cube root, so I'm going to rewrite that as 2 cubed times 7. So I can take the cube root of 2 cubed and get 2, and I'm left with the cube root of 7. And now I'm going to divide each of these exponents by 3 because we're taking the cubed root. And because it's an odd root, we will not put absolute value. 9 divided by 3 is 3. 6 divided by 3 is 2. And 1 divided by 3 is 1/3. None of those have a radical over them. None of them have absolute value. That is my final answer. So homework for tomorrow is page 4 in the Unit 1 packet. You do have a summer packet quiz coming up on Monday, so study the problems in the summer packet. Get your supplies and fill out that yellow paper, which is due Friday, if you have not already turned it in.